Now we are ready to get preliminary information about the file system from the data attribute of boot file, which is present in sector 0 of the file system. Let's bring up our forensic image in the hex editor. Our focus would be on sector 0, the first 512 bytes, that is byte 0 to byte 511 in the file system. A reminder, sector numbering also starts from 0 in the file system. There we have it. I have taken a screenshot of this hex view and added it to the slides. Let's head over there to process it. This table shows the list of information we will be retrieving from the boot file. As you can see, we have chosen only the critical bytes that will help us proceed with our examination. Regarding the other bytes, you can find out what they mean from the cheat sheet added after this video. Let us locate bytes 11 and 12 in the screenshot. The row offset is given in decimal and the column offset is given in hexadecimal. Byte 11 can be found in the first row at column 0B. The hex value in bytes 11 and 12 is 0002. Now, since NTFS stores values as little endian, we need to retrieve these values, swap them, and interpret as decimal to get the number of bytes in a sector. On retrieval, swap, and conversion to decimal, we can see that there are 512 bytes per sector. This confirms the theory we had discussed earlier. An NTFS volume is divided into consecutive sectors of size 512 bytes. Let us update this information in the table. Next, let's find out how many sectors form a cluster from byte 13. Byte 13 can be found in the first row at column 0D. Let us retrieve it. We will not do any swapping here as it is only one byte of information. Now, 08 in hex is 8 in decimal. This means 8 sectors form a cluster. It was mentioned earlier that the forensic image is of a 1 GB drive. This table confirms that in a 1 GB drive, 8 sectors would form a cluster. Let us update this information in the table. Now, let us find the total number of sectors in the file system from bytes 40 to 47. We focus on the second row, which starts with byte 34, and look 6 positions away for byte 40. Then we retrieve bytes 40 to 47. Let's swap and process it. After swap and converting to decimal, we get 1953124. Let's update our table. Now, for the starting cluster address of MFT from bytes 48 to 55. Again, we focus on the second row and look 14 decimal positions away from row offset 34 to get byte 48. On retrieval and swap, we get the starting cluster address of MFT as 81830. We saw earlier that the master file table does not start from sector 0 but starts at a location that is specified in sector 0. We just processed that location, bytes 48 to 55 in sector 0, and got the starting cluster address of MFT as 81380. Let us update this information in our table. Finally, let's find the size of one MFT entry from byte 64. Byte 64 can be located in the second row at hex offset 1E, which is decimal offset 30. So 34 plus 30 is equal to 64. We have the value F6. Now there is a special way to interpret this piece of information. First, the retrieved byte is written in binary. Then we look at the most significant bit, which is the leftmost bit. If this bit is 0, the binary value when converted to decimal gives the number of clusters that make up an MFT entry. If this bit is 1, the binary value when converted to decimal gives the log base 2 of the number of bytes that make up an MFT entry. Here, the most significant bit is 1. In binary, this is said to be a negative number. Let's convert it to a positive number first. For this, we take the 2's complement of the binary number. This is done by inverting zeros to ones and ones to zeros and adding 1 to the result. A simple binary addition yields 1010, which on conversion to decimal gives 10. Now this decimal value 10 is the log base 2 value of the number of bytes that make up an MFT entry. Let's talk a little bit of math here. A logarithm answers the question, how many of 2 do we multiply to get the value of x? So by the definition of logarithm, to get the value of x, we simply raise 2 to the power of 10. We get 1024, which is the size in bytes of one MFT entry. Wow, that was something. The developers of NTFS have maintained the size of one MFT entry as 1024 bytes from the time of its development. However, they may increase the size in future if required. Let us update this value in the table. Now we have all the required information. In this NTFS volume, there are 1, 9, 5, 3, 1, 2, 4 sectors numbered from 0 to 1, 9, 5, 3, 1, 2, 3. The sectors are grouped into clusters of 8. The master file table is found at cluster 81380, which is well away from the start of the file system. The size of one entry in the MFT is 1024 bytes. In the next video, we will locate the master file table and find which are the allocated entries in it.